So I did this project in the last couple of years with the help of Zurich and Frank Nefke from the Complexity Science Hub. So some of you might be familiar with central place theory, which is kind of this old theory of the spatial distribution of population, which was developed in the 1940s in Germany and has been retaken and repurposed by various authors later on, Denis Dumas, and also the economists like Paul Krugman. And this theory is quite simple. You imagine a wide plain with a bunch of farmers, and essentially the farmers produce all the stuff for themselves, or most of the stuff, but some stuff is indivisible. So not every farmer can have a church in his backyard. So you need some places where these farmers will place their churches. And these are these central places. So the farmers will commute to these places to access these indivisible goods, or these places will ship stuff to the farmers. And so you will get such a structure. And on top of this, you could have a second layer of places that kind of provides these center places, these smaller places, with goods that are useful for them. For example, these larger places have specific manufacturing facilities for specific tools that enjoy some kind of economies of scale, which kind of would concentrate them in larger places and ship stuff around. And then you can kind of iterate this reasoning and get larger and larger places. And so this creates what people call the urban hierarchy. So you have hierarchy of places that goes from small to large. And this urban hierarchy has a structure, and the structure of this urban hierarchy is kind of determined by a trade-off between the benefits of agglomeration and the cost of distance. So if the benefits of agglomerations are large and the cost of distance are small, you will have a lot of concentration in kind of a big place that ships stuff around to other places. And instead, if the benefits of agglomeration are small and the cost of the distance are large, you might have a more flat hierarchy, so more spread out. So essentially, yeah, this is the kind of intuition of central place theory that has been retaken out in other theories that followed. And if you look at the last 200 years, well, the cost of distance have dropped a lot. And you might argue that the benefits of agglomerations have increased. For example, this paper says that kind of the complexity of knowledge is increasing, and to have complex knowledge, you have to kind of agglomerate lots of different competences in some places, and this would be one of the benefits of agglomeration. And so these two things would lead you to conclude that kind of urban system that developed more recently, so with lower costs of distance and higher benefits of agglomeration, should have steeper hierarchies. So should have should be more concentrated in their larger cities. And this is the thing I will explore today, mostly. Why is this important? Well, if you think about kind of cities and urban hierarchies, there's been various work that has shown that kind of, with authors here in the room, also Luis Betancourt, that show that kind of various quantities scale non-linearly with city size. And this implies that large and small cities are kind of qualitatively different things for people to live in. And so if you have a different distribution of the hierarchy, this will affect the entire kind of functioning of society. It will affect its crime rates. It will affect kind of the pollution that the society generates and this kind of stuff. So this is why kind of these urban hierarchy questions are relevant. And if we can assert kind of a statement like this, we could say that the countries that are developing now, their urban systems, will in the future have very, very kind of steep hierarchies. So the new urban systems will be dominated by huge cities. So what do I mean by this statement? How can I make it precise? This is a typical urbanization curve. So on the x-axis, you have time. And on the y-axis, you have the share of the urban population, okay? So you can see that over time, the urban population grows. The share of the urban population grows, but it kind of does so slowly. Then there's an inflection point, and it kind of goes fast up. And this inflection point is around 20% of the urban population. So what I'm going to do is I'm going to use this 20% urban population to define the birth date of an urban system, okay? For me, an urban system is born when it hits 20% population. And this would be my x-axis, okay? So urban system that developed recently means urban systems that are born in more recent years, so more towards 2000. And urban systems that developed like long ago are urban systems that are born in 1800. And this means when they hit 20% urban. And then I want to define what a steeper hierarchy is. And here I use the Gini index. The Gini index is a common kind of metric of inequality. So it measures essentially how unequally population is distributed among cities in this case. Typically, it measures how unequally wealth is distributed among people, here among population among cities. So my y-axis is the Gini coefficient. And here I've taken the year 2020. Okay. So the hypothesis above, reframed in this terms, would be that urban systems that are born later, so born with a birth date towards 2000, have higher Ginis, so steeper urban hierarchies. But if you plot, this is a plot for all the countries in the world, roughly, and this doesn't really seem to hold, or at least not in this raw form. And so my question is, why doesn't it hold? And how can we kind of understand what's going on? Given that we have this image from central place theory that tells us that kind of as transportation costs go down and agglomeration economies go up, we should get more concentration in large cities. So I collected two big data sets. The first one powers the plot that you see before, world cities 1975 to 2020. And I have every 5 years a snapshot of all the cities in the world from satellite imagery. So satellite imagery that gives me squares like this, tiles of the world. For each tile, I know the build-up area and the population. And so I can infer kind of the degree of urbanization of a tile and its population. What I do is a simple clustering algorithm that essentially creates cluster by putting together tiles of the same that are adjacent. So like this, you can see my clusters. The black squares become these clusters. And now I have all the cities in the world throughout this time. And then I compiled the second data set from the US Census. The US maintains a census every year, which has been digitized. And with this digitized data set, essentially I can track the population of the US, the spatial distribution of the population from 1860 to 2020, so over 160 years, which is a really long time frame for this kind of studies. This is only roughly 50 years. And we can see kind of some long-term dynamics. So what do I find in this data that is relevant to my initial question? So one of the first things I looked at, or one could look at, is how city population and growth are related. So on the x-axis here, I have the population in my city on some year t. Okay, so let's say 1860. And on the y-axis, I have the city growth in the following 10 years. So from 1860 to 1870. Okay, and this is the curve of city population against city growth in 1860 to 1870. So essentially, larger cities, cities with higher population in 1860, grew faster. So at a faster rate from 1860 to 1870. And then I can kind of do the same kind of exercise for other years. And this is a bit later, the green curve, and much later, the purple curve. Okay, so over time, what we observe is that first, we have like fast divergence, larger cities growing much faster. And then over time, the divergence goes down and kind of flattens out, or not completely flattens out. Another way I can kind of look at this thing is by looking at the slopes of these curves. So these are a one-dimensional summary of the entire curve. I just fit a slope like this. Up there, with that regression, I call this the divergence rate. So it's the rate at which cities diverge. If large cities grow faster, the larger this rate, the more the larger cities grow faster. Okay, and so here I plot the year in my data set against this divergence rate, which is exactly the slope of these curves. And what I observe is that essentially as time passes, the divergence rate goes down and it stabilizes around roughly 0, a bit above. Okay, so what this shows is that kind of urban systems tend to diverge in their early stages, and then this divergence kind of slows down over time. And this is compatible with theories, again, of Denis Poumon, which kind of interpret this in terms of scaling laws. So this is, now I looked at the US temporally, but since I have this large data set of the world, I can look at cross sections. So instead of using the same urban system over time, I can look at different urban systems at different stages of their development. And so this is Ethiopia in 2000. You can see that it's an urban system at the start of its development. So the medium-sized cities are still growing slower, but the larger cities are kind of picking up. And then if we can move it to China in 1980, which is a bit at a further stage, we see this divergence pattern as in the US in kind of the recent times. And this, then Nigeria in 2010 is a bit further down still, and we get kind of this decreasing, and then we get Brazil in 2010, which is an urban system that's roughly 100 years old, 120 years old, and we get this kind of flattening out or decreasing. And one way I can try to reproduce the other plot before, the one with the divergence rate on the x-axis and the year on the y-axis, is I can order urban system by their age, okay? And their age is defined by the number of years since their birth, which I priorly defined as the year when they hit 20% urban. So an urban system is born when it hits 20% urban, and then it has an age. For example, I don't know, the UK has 200 years. Its urban system hit 20% 200 years ago. And Ethiopia has 0 years, it's just born. It hit 20% just in 2020. So this is the curve you obtain if you do this exercise. And as before, we observed that the young urban systems, so urban systems that are born recently, tend to diverge rapidly. And then this divergence kind of slows down over time. Okay. And these are kind of the various urban systems on this right thing. So Ethiopia, China, Nigeria, and Brazil plotted on the thing. So this is Ethiopia, an urban system that is not yet born, and this is Brazil after kind of 100 years of development. So the whole point here for the previous plot is that urban systems kind of diverge over time. So when I do this kind of comparison, okay, I'm looking at different urban systems that are born in different moments, but at the same timestamp, no? So I'm comparing urban systems of different ages. It's a bit like if you compared my citations with Dirk's, and you say that Dirk is a better scientist than me, just because at the moment, my citations haven't yet catched up. So this is kind of this similar type of comparison. So what we need to do to kind of extract the signal from the noise here is to rescale everybody to the same year. So again, I can define the age of an urban system since the time it hit 20% urban. And then what I do is I remap urban systems either back in time, I backtrack them to 100 years after they hit 20% urban, or I push forward them to 100 years after. So now I can have all urban systems that are 100 years old and reevaluate the plot as before. And now I see that the birthday of an urban system is fairly well correlated with its Gini coefficient after 100 years. So essentially, after 100 years of your development, if you're born later, if your urban system was born later, you get more steeper hierarchies, okay? So essentially, what this would suggest is that urban systems that are growing now will have very steep hierarchies. And this is another way to see this. I can bunch urban systems by region. And so I have Europe, which is the first developed region. Then I have American, Oceanian, Middle East, and North Africa, which should develop a bit later, and they tend to have higher urban systems, this higher kind of steeper hierarchies. And this is always with this reformatting of 100 years later of your birth. This is East Asia, which has the highest levels of urban hierarchy. Like there's crazy things like South Korea, where 50% of the population lives in Greater Seoul, of the entire population of the country. And this is the projections for Sub-Saharan Africa, which kind of would put it at the par of American Oceania in the future. So theoretically, it could have very, very large cities. Thanks for your attention.